Hi guys, welcome back to the shop. Hey, today I'm gonna see what I can do with this stator. I think it's simpler than I initially thought. We're gonna kind of clean it up a little bit, and I'll show you what we need to do with the wire. I think it's a lot easier done than we thought. So let me get you overhead, and we'll get going on this thing. Okay, this wire, it just runs from here across, and I think what happened was the eyelet broke off on this, and this is the best way they could fix it. They didn't have an eyelet, and I don't either really. I mean, I've got one, but I don't think that's what we need. I'm gonna make one out of copper, I think. That's what it looks like is on this end. I'm gonna go ahead and pop that off. I just think that it's a little simpler than what I thought. You see stuff like that, and you know, the first thing that goes through your mind is, oh my gosh, you know, what have they done? Okay, so we just pull this out. And the thing kind of got down in, there we go. Okay, see, they've just got it like a flattened out area on the end of the, I guess I could make a new one out of a piece of Romex and try to do it the same way, or I could solder one on, but I'm going to experiment a little bit with some Romex, I think, and just see what I can do there, and I can transfer this over. But that's what they've done. This looks like they just smashed it here and then made an eyelet, and it just probably broke off from vibration on this end. So they soldered a wire on and just wrapped it around the bolt. Okay, I've just got some Romex here. I think this is about 14 gauge. It looks like it's a little bigger maybe than this, which isn't going to hurt anything. I'm going to see what I can do with a hammer. I may have to take it over and put it on the press. Yeah, it's not really doing what I want it to do. You know, that's sure what they did there, I think. It just looks like it's some of this that's smashed. Let me take this over on the press and see what that can do to it. Okay, this is what I'm ending up with. It really, to get this 90-degree deal like that, I'm having trouble getting that, but I think I can get this in there okay like that, and it'll run across and not interfere with anything. And then I can just come on down here and get the other one the same way. And what I do is I loop that at the end, just like you'd turn it around a screw, and then put it in the press and squeeze it, and then just kind of trim off what the excess is. So I think that's going to work. I've got to get the sheathing on before I do anything else. If I mess it up, I guess I got plenty there to do it again. So this is the next thing I need to do, is get the sheathing off of here, and to do that I'm probably just going to have to cut this end off or unsolder it. Not really looking to do that. So we can just do this. And that's how they did it. Okay, let me see what I can do. Okay, this is all I'm doing. I get that loop made, like I say, if you're putting it around a screw on a switch or something like that. And once you get done with it, you can just kind of trim it up. Yeah, just like that. Then you just kind of trim around the outside and get your rotary file and go in here and clean that up to look like that one. And I just take my rotary file and go in here and kind of clean that up a little bit. You gotta have something to hang on to besides that wire because it heats up quick. I just took my 10 snips, kind of roughly cut it. And then take it over on the bench grinder and clean it up. Okay, I think we've got her pretty good shape there. So we'll see if we can get it back in there. Right there. I may have to maneuver it a little bit here to have my sheathing. There we go. It's catching right here in the middle. And then it slides on the other one. There. Well, it still did it. I think I'm going to have to take this wiper off. That's, I think, what's giving me the problems. Yeah. Okay, I need to get under that wire too. Okay, and I can kind of twist this to meet my needs there. Okay, so we've got a brush that goes on there too. See if we can get that sheathing. That keeps being an issue there. Okay, and then that brush goes right in there. So I can go ahead and, oops, things are a little close here. Again, we can just kind of twist this to suit us. It's going right there, so we're going to do it this way. It's dinky, stinky to my old big hands. Okay, so we should be able to get that one in there. So that's our repair. I think that's going to work just fine. Okay, I'm just going to take some electronics cleaner and just clean this up the best I can. Okay, I went ahead and moved that. I just wasn't happy with, it was really close to here and here going through there. So what I did was I came around the outside and I actually made it out of some insulated wiring, house wiring. And that way I've got it double protected. I put a piece of sheathing on top of it, plus it's got the white sheathing on it. And I did the ends the same way. I just wasn't happy with that. I was afraid it was going to short out on me, so I just decided to do it that way. And he had a set of points here, so I'm just going to go ahead and put those on. I'm going to have to find a condenser, and probably won't be able to get one of these. I looked kind of quickly, and they're just not out there. Probably going to have to get something with a shorter lead and put the lead out. I think I better maybe get a little brushing action underneath that so it'll ground good. Looks like we've kind of got some substandard points here. They're not quite wanting to set in there. There, maybe I got it. Let's see, we're down a long way. Yeah, that frame's not a lot. You know, it's a little bit different. I just need to tap that up just a little bit. Kind of went a little further than I wanted it to. Oh boy. Just nothing like OEM stuff, I tell you. There, that's about how it was, I believe. We'll have to set the timing and everything. So right now we got it on there, and like I say, I'll probably just have to cut the wire and or unsolder it and resolder it. We'll see what I end up with. Okay, guys, this has got we've got a lot of corrosion here on the point lobe, and I put a screw through that. I'm gonna put that in the lathe, and then I'm gonna take some sandpaper and see if I can't remove some of that. Otherwise, it'll just end up rubbing the point block, you know, the little phenolic block on the points. It'll end up just wearing it off. So we're going to clean that up the best we can. That rust just really messes up things. The idea here is just to take off enough to keep that wear block from wearing. So you can still see some pitting there. It's on both sides of the point block. All right, let me work on this a bit. I started with some 220 and then went to 400, and now I'm using crocus. You're still going to see it there, but it's going to be smooth. So I think, you know, other than trying to find another one, that's about all you can do. And you might remember we had a little problem, not a big problem, getting this shifter shaft out. I thought it was bent, but I don't really see any any bend that would cause that much of an issue. So it must have been a little bit of rust down here. So we'll just clean that up. Okay, guys, thumbs up, hit that notification bell, and please subscribe. Thank you very much. Okay, guys, need to look at this Kickstarter here. This is the one that came out of it, and you can see this what's happening here to the case. Now this piece right here fits into this groove right here. That's the stop. When it comes back up, that's the stop. So it starts right there, and then as you kick down, it usually stops by itself when it hits the foot peg. So it's just about straight down then. I think you can see I've got a little mark here on the top of the shaft, and that's where it is when it's up, when the kicker is up. So as you kick this around, it's going to stop right about there for the most part. And you probably can't really see it very well, but you can see that's where this is right there, and it's starting to come into the case. Let me go grab a light. Okay, I think you can see it there. See how it's coming into it? And usually the first thing that happens is this kicker, you see it splined right here. it starts slipping on that spline. And this one actually has not, if it has, it's very minute. I've already had this apart, and it looks like it has not slipped. If it has, it's just a little bit. So I think what we're going to do is go ahead and TIG weld this right around here, and then put it in the lathe and go ahead and trim it back down so it'll rotate okay. But what happens, here's the NOS one here that I've got, and I want you to note too, see, Yamaha knew they had a problem, and you can look at the diameter of this right here and look at the diameter of the new one. It's bigger. They knew they had a problem, so they wanted more surface area. So they made this bigger. That's the only thing that is. I think I've seen 3, maybe 4 different types of these shafts, and they usually have a different little stop here on them. These 2 stops are pretty much the same except for that diameter. So what I do is I look at, when I pulled this one off and took it all apart, I'll look at the relationship of this hole where the spring goes to the stop right here. And that's how it should be, just about in line with it. What happens is as this starts slipping, this will move around. And at that point, it's just going to get worse. And what you can usually tell on the kicker is that it starts coming up and hitting the case. Let me grab that case. Okay, so what you'll notice is this kicker, it'll start coming up here, and it'll start hitting the case, and then it'll kind of pull it out a little bit, and it'll keep coming up until it just can't go up anymore. And that's indicative of that shaft that's slipping here. And what I do generally is I verify the position. If it's not in the right position, then I'll move it there. You can just, sometimes you've got to press it off, press this piece here off, and then get it located right and press it back on. And then I go back here and I trim this a little bit in the lathe. Then I take a TIG welder and weld it, and then put it back in the lathe and cut it down flush again. But that's what's happening there. Now this carnage that's starting in this case is from a slightly different issue. It's still this problem, but what's happening is when this thing comes over here and you're kicking this lever down and out at the same time. And when you do that, it's pulling up on this, and it's allowing this to come on up into here like this. So how do you fix that? Well, you put the case on, you put the gasket on, and then you pull it up and down and check it with a dial indicator and see what the movement is. And I'm going to show you exactly how we do that. And then Yamaha actually shows a shim, but very few bikes have it. And that's the problem. In this case, I will go over on the lathe and make a new shim at whatever this checks out to be. So let me get this kind of assembled here. I can kind of show you what we're doing. I'm just going to go back in here, and remember this piece is going to fit right here, and this little spring is going to fit right here in this pocket. And it doesn't matter where that thing is, you can move it. It just slides on there. So the first thing we need to do is make sure that we can get the stop where it needs to be. And then make sure this goes down into the pocket. And there it is right there. And I'll just go ahead and wrap this spring and place it where it needs to be. Okay, so this is all the way down. Now it's important that you put your gasket on because that offers some spacing. And make sure that there is no gasket on your side cover. And go ahead and place that where it needs to be, and then get you a couple screws in there. I think that gasket slipped on me a little bit, yeah. You just want enough in there to hold the two cases together. So they don't move on you. All right. Now, you see this movement? That's what's causing that issue on your case. And a lot of times if you get the shaft that's slipping too, it'll really tear up that. So it's a little bit of both actually. So what we're going to do here is we're going to get our dial indicator and get that, push it all the way down and zero that out. And this isn't rocket science, it's a close thing. But see, I got to hold that kind of down. About 35. About 35 thousandths is, I'm measuring in thousandths here. So we don't want to take up all that slack, but I'd say 30 thousandths is where we need to shoot for our shim. That'll keep that from moving up and then sliding into the case and chipping away at it. Now let me show you some stuff in the book. But like I say, this is, I've kind of got to hold it down here on the table. But I can tell that that's about 35 thousandths max. Okay, I've got the book here. And right here's your shim. Now this is the old book. I believe, let's see. Yeah, here's what I got offline right here. And it's showing number 10 to be the snap ring. So it doesn't even show that washer, that shim. Right here. Here's the snap ring, there's your shim. So that confuses some people. But on these older books, if you've got these and you're going to keep them and you want to be able to maintain them, I would recommend finding a parts list. It's very, very useful to you. And let me show you why. Okay, I need to make that shim, right? Okay, I go to 810, which is, number 10 is the washer. And it's a shim. And it gives you the exact measurement of that shim. 20.2 millimeters on the ID, 28 millimeter on the OD, and 1 millimeter thick. And 1 millimeter, I think, is about 30 thousandths. Hang on a minute. Let me get my caliper. Okay, I've got 1 millimeter in here. It's 40 thousandths. 39 and a half. So we need to make this for about 35. No, we don't need to go by this. We need to go by our measurement up here. And we'll take the OD and the ID from the book and turn one out on the lathe. And we're going to make it about 30 thousandths. And that will prevent that from the shaft coming up and continuing to come up into the case on the inside. All right, I've got a piece of DOM tubing here. I'm going to use that to make my shim out of. It's actually pretty close. We're at almost 32 millimeter and we need to be at 28, so that's just a couple to come off. And the inside, I've used this for something else before. Looks like we're at about 20 and we need to go to 20.2, so we're almost there. And then of course our 30 thousandths thick. So I've got just a little bit to take here on the inside, so we'll get with that. Okay, I believe that's going to work. So we want to move it in the width of our cutting tool, which is 0.087. Right there. And then 30. Right there. So that should be our washer. So let me get to cutting it here. There's our washer. Right on it. It'll go right about there because it'll go up against the case right here and prevent that from moving up and down. Okay, I just want to show you what causes that shaft for the stop to slip on the shaft. See, when you kick this down, you're going to run into the foot pegs right there, and it's just a little bit more than 180 degrees that moves. And when you get to that point, it pushes out a little bit too, and that's why that's coming up onto your case on the inside. But the reason this thing slips is this. If you'll kick this thing down and then slowly lift your foot off of it so it comes back up, you'll never have that problem. It's that abrupt come up like that, and what you'll see on the outside is this will keep moving up and up and up until it's hitting the case, and then if you let it go, it'll continue to kind of dimple the case, and and it'll be eating up your case on the inside too. So that's what you don't want to happen. So when you're kicking this thing, just kick it all the way down and then let it up. Just don't let it fly up. That's what causes it to slip. Now, if you've got the new shaft, it'll probably be a long time before that happens, but why chance it? So what we're going to do on this one, since it's just started, it's an old shaft, like I said, it's got the smaller diameter on it. So we're going to go ahead and cut just a little bit of the shaft out where the stop is, go back in and TIG weld it, and it will never happen again, or it'll never happen to start with. But that's the cause of it right there. And what you want to do is eliminate as much of that in and out play as you can, and that way it won't keep creeping up on the inside of the case. Like this. So that's what's happening. That's why we're making the shim, is we don't want this play to, because if you eliminate most of that play, you don't want to eliminate it all. You want a few thousandths. In this case, we're going to have about 5 thousandths. But it'll stay down here instead of starting to creep up here. I've seen them go all the way up there. You know, as far as the lever will allow it by hitting the case on the outside. Okay, let's go ahead and get this disassembled again. Not a lot to it, just you've got a couple of clips like this. You lift that spring up out of there and pull it forward. And you've got your other clip right back here. And you've got that. Sometimes it's kind of difficult to work it off of that clamshell. And then you can pull your gear and your spring off. And then we're down to the bare shaft. And I just want to show you, this is the NOS one again. And you can see here on the end that this area here where this spline is, or knurl to hold it, it's smaller than this one. This is the new one. There's a couple different variations. There's one where this stop looks a little different. There's these two and that one that I'm aware of, and there may be another one. But anyhow, this is how you want to look at it. like I said before, you want to get this just about straight up and down, and if you was to draw an imaginary line like this over to that, it would be, this hole would be right in line with it. And you can see on this one that it has just moved a little bit. It's not a lot. So we're going to take it right there, and I'm going to take it over on the lathe, and we're going to cut a little bit of this spline area out, and then come back in and TIG weld it, and then we'll put it back in the lathe and true this up. That's how we fix them. Okay, like I say, I'm just going to get right in here and take a little bit of that material so I can get a little bit of weld in there. And I've got to be careful that I don't get any weld on the shaft. I mean, it's not the end of the world if you do. You're just making work for yourself. But we'll see if we can do without doing that. I think they call this tree panning or something like that. Just making a place to get some weld in. That should be good. Alright, we'll see if we can get a little weld in that groove we put in there. I'm just using some 023 MIG wire to do the welding, and I think you can see the finished product there. We'll take that over and we'll cut that down to the so that it's flat, so that won't be banging in or cutting into the case. Now we're just trying to get that shaved back down to where it's not going to interfere with the case at all. Just take it easy. Just a little bit more, I think. It's real close here. Yeah, I think that's good. Yeah, should be good. Okay, guys, let's See if we can get this, see how it's going to work for us. And we'll try our 30,000 shim right there. Okay, got her zeroed out here. I got some preload on it. Looks like about 3. Yeah, 3 or 4. That should do it. Should be good. That way it's not going to pull out, and it's not going to allow that stop to slide up into the case. Okay guys, I had a camera malfunction on when I was doing the armature, so let me just show you what I did here. So I just went ahead and turned that and then undercut it, and I just use a scribe to kind of start that, and then I found a screwdriver that would just fit in there, so I could take out the mica in there. So this should work real good for him, and everything should be in good, good contact, and work the starter and all that stuff like it should. So I don't know what happened, but I just didn't get it. And one thing too, if you're a lot of people will turn these or spin them and use sandpaper on them. You want to make sure that it is sandpaper. You don't want anything that is metallic, crocus cloth or anything, or aluminum oxide, any of that stuff. You don't want that, because those fines can get into the wiring, and you don't, it can cause a short. So you want to make sure that it is like a 360 or 400 actual sandpaper. I think what they call garnet. Okay, so I think we've got almost everything repaired except for the crankshaft. That'll be a video itself where we'll go in. Hopefully we can just put a new bearing and pin in it and a couple new thrust washers and go on down the road. Most of these AT ones and CT ones that I've done, unless they've had water in them, they're good. Just like the 90 Twin, those rods were just fine. So, no use throwing stuff away like that if you don't have to, and as long as they're good. But we've got the crank to do, we've got the boring to do, but probably the next thing we do, we'll go ahead and assemble it. We'll get the bearings in, we'll get the seals in, we'll start the assembly. I've got pretty much all the inspection done. So the only thing that, I think I've got all the parts I need. So we'll do the lower end build, then we'll probably do the, we'll do the crankshaft, then we'll do the lower end build, and then we'll bore it, and then we'll build the top end. So we've got 3 or 4 more videos in this series for this engine. But I think I've got everything repaired that we need. Repaired, or whatever work I need to do to, like with the shim, to get the shim right and that sort of thing. So hey, thanks for going along on the ride. See you next video.